Alright guys, let's have a look at the next job we're going to do on this, and that is the slide bolsters. And we've got three. We've got two side bolsters and we've got a top one, and they contain our main sliding elements inside. So let's just remove some of the visibility on some of this stuff and we'll have a look. We'll get the ram out of the way, we'll get this top one out of the way. Give us a better look at what we're dealing with here. So in two directions, so top and side, I have these adjusters with a pad on the bottom which works on this slide. These slides are made out of a high density plastic, HDF or HDPF I think it's called, which acts as my wear surface, so I can apply a load to take out all the slop and any vibration in that ram, so in from the top and in from the side. And these plates are effectively floating. They're not fastened in any way, they're floating within an encapsulated groove which we're going to be machining out. I'll just remove that off so you can see that groove that we're going to be, all that space we're going to be machining out, which is going to encapsulate that. And I don't want these to be a tight fit. Plastics will grow with oil, and I'm going to be well lubricating these. So plastics do grow with moisture, fluids, oils. So we don't want to make them too tight, because when they do grow, they're an absolute pain to try and get out. So the first one we're going to be kicking off with is, I call this the top side bolster, which will have the adjusting screws in it for taking up the slop. I'm also going to be including lubrication, and I always bang on about lubrication. It's got to be well thought out and practiced. Parts don't get lubricated, they seize up and things become a terrible mess. So I like to try and put as many lubrication points around on friction objects, moving objects, as I possibly can. And I've done that with the slider that I've got on the milling machine. All the slideways are lubricated, all the pins are lubricated. Anywhere there where there's a bush, on the crank arm for example, wherever there's a bush, I've got a lubrication point that you can get access to get oil into those moving parts. So I call that one the top side, and we've got this bottom one here, which is a non-adjusting one if you like. These will be bolted through into the main housing, or this main plate I should say, the slide plate, with 3 socket-headed cap screws. Then we've got the cap screws that secure the top plate on top, so a little bit like Swiss cheese, just working around all the fastening points. And what I will do with that top plate is I'll pop a couple of dowels in, or thread a couple of dowels into place, so that that bolster goes, or that top bolster goes in the same way every time. Now these are then keyed into those pockets that we've already pre-machined into this slide plate. And you might remember I put those toolmakers corners on, so we don't have any foul points. I was going to knock a 45 onto the bottom of those blocks, but I've gone away from that. We'll slot them in as they are. I'll just remove the visibility on that so we can have a look at, that's the pocket that we've machined in. And you might remember it had a raised surface in the middle there, and that's for one of the slideways, the bottom slideway to sit on. And it gets encapsulated with the side plate. So these are all precision fitments into here to make sure that everything's kept square, everything's kept stable. Makes life a lot easier. Right, let's have a quick look at the actual drawing. So this is the one we're going to start first, is this top adjusting side bolster. So it's 17 wide, so we're going to be doing that out a bit of 20mm plate. It's 35 deep, so it'll be a bit of 20 by 50mm plate that will knock down. And once again, I'll do those as individuals. I'd love to be able to do them as a slab and do two together, but my vise isn't big enough, and I find that when I do that, things are going to warp and twist a little bit, so we'll do them as individuals and get them knocked through. So we can see the cavity there for our slide. I've got an oil point in there. What I will be doing is I put a little pitot tube, a little copper pitot tube inside here, so that the oil passes through into the face where it's got to be lubricated and not back into the backside of the slide. That's where we've got our little adjusting screws. We've got a little pad there that's or a little recess there for the pad to sit in, and when we button those up, we push up against the plastic slides, which then pushes up against the ram. Fastening holes to do. It's just another view showing the adjusting screw recesses. So lubrication, and once again we've got a fair bit of drilling and tapping to do into that unit. And that's what the ISO looks like. So that's the one we'll kick off with first. As I said, I've notched corners at assembly. I won't be doing that. As I said, we put those tool makers corners in. The second one we're doing is the bottom fixed side bolster. So this hasn't got any adjustments on it at all. Once again, we've got our little oil hole that we'll put that copper pitot tube through. It's the same system as the slotter that I used on the Bridgeport, and it's worked extremely well, that lubrication system. And then we've got the side bolster top plate that we talked about there that I'm going to dowel into place. So everything's fairly straightforward. It's just going to take a little bit of time to get this together. So we'll see how we go. Now at work I've got some rather big shutdowns coming up, so I'm starting to do a fair bit of pre-work for those at the moment, which is going to suck up a lot of my workshop time, so I might find that this project does slow down a little bit. Yeah, unfortunately, other priorities take over our lives sometimes. But it's nice to have something ticking over in the background and something else to think about. Alright, so let's start getting some material organised, and we'll start cutting something up and getting some machining done. Alright guys, we'll catch you soon. Where everything starts, cutting up the stock on the bandsaw. So I'll cut the two side pieces up, and I'll also cut the wider top section as well. So that's the second of the two side pieces. I've got to go and find a bit of stock for the top section. Right, we're just cutting the plate for the top section. So it's a bit of 100 wide stuff. I'm cutting that down to about 68 wide. It's got to be machined back to 63, and then I'll cut it off the length at 120 to clean up to 118. So this is a bit of scrap that I've got lying around. It's a bit gnarly, but I'll be able to clean up okay. Alright guys, we're going to knock this down. We've got to come down to 35mm, so we'll bring this side down to about 40, flip it over and do the other side. Then we'll machine them back to width. I'm going to leave about 0.2 on these because I do want to grind the outer faces. And we'll machine the pockets in. So we'll try and do them as much as we can as a pair, because they're both the same, other than the fact that one has the adjusting screws into it. Alright, we'll get it started. I'll take a couple of mil out for the time, we'll see how that goes. Well, that's I overloaded it. We've got an error. Let's just flick our machine off and flick it back on again. BORN, which is a nightmare for those little things, and sometimes it comes good and sometimes it doesn't. Let's see how it goes. In the settings you have a certain current set that you have on these, and if you overload the motor, just a little bit, she trips out on you, which is what's happened on this occasion. So yeah, we'll cut back on our depth a little bit, I think. In fact, I might even change that cutter out. We might put a different cutter in there, I think. These are a nice universal machine, but yeah, they certainly have their limitations. Vibration being not the least of them. Let's give this bloke a bell. Alright, well, I'll carry on with that. I'm not going to couple of mil off at a time. Just take our time on it. I'll flip that over and machine that back to width, and I'll bring you back when we're getting close to the final width dimension on this. Alright guys, we're getting down to the last cuts now. I should have about 0.05 after this. Maybe 0.09, nearly 0.1. We'll see how we go. Alright, the most important thing about this is that we've got them parallel. .0102. We'll check it for parallel. What we'll do next is I might set up and get the edges all to length, and then we'll start skimming the top and bottom faces on these. Get ready to cut the pocket. Alright, we'll see you back when we're ready to start that those edge cuts. Right, so these came up bang on parallel. We'll see if you can see. It's 35.0. Oh, it's about 0.005 under. So both are the same, so I'm very happy with that. They're spot on parallel and spot on size. Right, as I said, we'll set up and we'll get that end mill sorted out to get those ends cleaned up. Right, I've got to bring this down to 7/8. It's measuring up at about 19.45. Bit of an odd size. Anyway, yeah, so we'll knock about 1 mil off each end, off each side. I want to leave this about 0.15, 0.2 mil up so that I can do a final grind on that to match those machined pockets that we've got on the front faceplate. Alrighty, let's get into it. I'm doing the finishing cut on this backstroke. One reason being that my head is out slightly, so it's doing an onion ring cut on the back by about 1 thou. So I'm quite happy with the surface finish that's bringing up. Right, I'll pop the next one in, and we'll face that down before we do both together. Well, not together, but then we'll flip over and then we'll do the other side of it. So I'm going to leave about 0.2 mil full on this. I'm sort of half expecting this may bow very, very slightly as we take that outer skin off. Hence the reason leaving 0.02 on. I'll then pop them into the surface grinder and give them a quick lick down to the nominal size. Right, we'll bring you back when we've finished the other side, and we're starting to finish out machining on the final face. Right, we'll just do this final cut on this one. It should leave me with about 0.15, so it's going to be 17.15 thick. That'll give me 0.15 just to give a lick up in the grinder to take out any small dish that might be in it. This is hard to do in front of the camera, but we'll see how we go. 17.14 and yeah, 17.16, a little bit of a taper in it. That's better. About 0.01. Alright, I will machine the last one out and we'll set them up in the surface grinder, and we'll get them down to 17 mil. The pockets that these have got to fit in, I measured up at 17.02 I think it was, so they're pretty dead nuts on. So we'll get this down to 17. I just want these to be a very, very light tap in fit, very light push in fit. Alright, I'll get the next one done, and we'll come back onto the surface grinder when we're going to get these down to final size. Righto, we're about to start grinding this. I'll just move things back a little bit. I've just touched up, and yeah, we've got a low spot in the middle, and it's touching on the two high spots. Righto, I'll continue grinding these down until we get the sizes. So I'll clean up on this side here, then I'll flip them over, and we'll get them sized to fit in the pockets of the adjusting plate. Right guys, I'm going to mill these as a pair. I'll mill them together, and once again we're going to use the Joe Pioski cornflake packer trick. I'm just going to slip that in there, a bit of cardboard. So when I did lock them up, the top one moved around. Now they're locked up. Righto, give this a clean up. I'll keep going with that, and I'll bring you back when we're getting down to our sizes. Okay guys, got a little bit of a problem here, nothing too insurmountable, but just a bit of a pain. So I've got these to width, and it's fitting in there beautifully. I've got around about 0.05 of a mil just to take off that, but I wanted to be able to get the lengthways fitting first so that I could work and get that absolutely right. However, this top one, although it's fitting up beautifully there, when I milled the pocket out, I've left a very small divot just there. So I'm going to pop this, pretty hard to see with this camera, but there is just a very small divot just in there, which is just sticking out. So I'm just going to sit this up in the mill again and just give that a very, very light lick just to take that little divot out so that I can fit this block in again. And they're a fairly neat fit, these blocks. Alrighty, we've got them sitting in there now, so it's hard to see, but yeah, we're just giving that a little tiny lick to get that little divot out of the way. And they're a very neat fit in there. Alright, well I'm going to set up in the surface grinder. I'm just going to take that 0.05 off the width, or off the thickness I should say, and we'll get these fitting into place. Then we'll start looking at machining out the pockets for the wear strips for the slides. Hi guys, we're going to start milling the pockets out, excuse my arm, out of these guide blocks. So we're going to mill these pockets out so that we can fit the slides in. Now, sometimes it's always worthwhile buying your material, particularly if it's going to be a stock size, before you start doing any of your machining or even some of your design work. So this is the stock stuff that I bought here. That's measuring up at 5.95. This is some stock that I bought from the same supplier when I did the slotting head for the milling machine. If we stick that in, 84, so it's a 0.1 of a mil difference. It's probably not as critical on this particular job, but I want to try and minimize the amount of adjustment on these slides. I want to keep them tucked into the pockets as hard as I possibly can. So I've designed around that 5.95 dimension there when for getting the depths on these. Let's get into this. So I've got a 12 mil cutter in here at the moment, so I'm going to rough all this out down to depth. I'm going to leave about 2 millimeters around the boundary to machine off, and I'll stick a 6 mil cutter in just to finish all that out. So what I also do too, and I'm starting to learn this, just a quick rough mark out what I'm doing where the pocket is, so I don't get my left and right hand elements mixed up. And little marks on the top, little witness marks. That's the top, and the one I've got in there is that's the top bottom. So just some little witness marks to help me. So if I start getting a bit vague or a bit tired, I can. It's a bit of a heads up to say, hang on, you've got that in the wrong way. You nitwit, turn it around. All right, let's make a start on this roughing out with this 12mm carbide cutter. All right, guys, we'll make a start on this. So as I said, we're going to rough this out. We'll leave a boundary edge to come around with the 6mm cutter, so we end up with the 3mm radiuses in place. But, we'll start off 2mm deep, and we'll make our way around. Check this for parallel now. So I've given the top a bit of a stone just to clean it back, and it's measuring up at 3.95 on this side here, measuring up at 3.95, so that's dead parallel all the way through. I'm going to take that back to 0.05 to get it back to 4, and then we'll come in with our 6mm cutter just around the boundary, take that last couple of millimeters off. The size. Oh, beautiful, all done. Right, we'll put the 6mm cutter in here and we'll just go around the boundary and we'll bring that back to size. Now size isn't really critical on this. I can make these slides to suit, so for a couple of points out it's not going to be the end of the world. As I said, we'll just make the slides to match. Depth on that is fairly important.
done, what I might do is I'll just go around that periphery one more time just to make sure we've got no angularity in it. Not that it's critical, but I just want to make sure that we're on the mark there. Alright guys, this one's finished. I did run it up and down with the 6mm cutter just to give it the slightest lick, and I'm down to 4.02mm all over, so my nominal was 4, so I'm very happy with that. Nominal lengths, I'm within 0.02 again, and same with the depth, so I'm happy with that. We'll set the second one up, and I'll start knocking that one out. Alright guys, we'll see you in a tick. Alright guys, we're going to drill through and counterbore for the M6 socket headed cap screws first. Then we're going to do some drilling and tapping that's going to hold that, that top plate down. So we'll get these center drilled up first. Right. Right, well we've got the drill chuck set up, we'll do the 5mm for the M6 tapped holes for the roof before we swap over to do the counterboring on this. While we're here, I'll tap these 4 out to M6. Righto, tapping done. When I take those out, I'll deburr them. Right, we'll counterbore these socket-headed cap screws now. Right, I'll counterbore this out now. So I'm using a 10mm slot drill here. Counterbore size is too big, it's going to get up too close to the edge. So the heads are going to be fairly well sized to this, but I haven't got a lot of room to work with in here. So I'm going to go down to 7 because these need to be below the surface for that cap to lock down on. Slide it up a bit. Righto, all done. I'll set the second one up and we'll do exactly the same. Righto. As you can see, I fitted this one here up and it was absolutely spot on. The threads are just sticking through a little bit on that other side there, so. I think I might have dropped one of my screws. Yeah. Maybe another one. Alright, you can see how easy they go. I'll tell you what, having a DRO basically turns that milling machine into a jig borer. It is just absolutely spot on. There's no need, well, very rarely do I mark anything out. I set my datums up dimension from those datums, and away we go. So that there is a perfect fit up. You can see that. It's poking through the other end, but that's okay. So that's what we've ended up with. So I'm really happy with that. Right, so the next job I think I'll move on with. Actually, yeah, in this top one here I've got a drill and tap and then counterbore back inside for the adjusting screws that work up against that that slide, that bearing face. So we might set up and do that next, and then we'll have that's basically all the machining completed on those plates. And we'll start with the top then. Start getting that knocked over, but really happy with that. It's just been a shoehorn fit the whole way through. Alright, so just going through centering these off now, then I'll drill through with a diameter 5 to tap, and then we'll use a 10mm slot drill, and we'll counterbore these Alright, I'll drop this down and we'll tap them out, bring it back up, and we'll do the counterbores. Alright, we'll get set up with the counterboring. Right, so we're going to go about 1.5 deep on these. Righto, done. We'll take that out, we'll deburr it, and we'll get started on the top plate.